Am I clear and continuous, my
Yeah,
voice?
yeah.
Fine, fine. Okay, so this is basically a paper which I discussed in a flow, and we did not go in depth. So this one, particular paper is actually a framework. It is not basically for securing and all. So this is basically a paper which helps you understand what are the different like this is one approach of handling the drone network. Okay, so this was actually a paper which I have read from end to end. So in this they are actually trying to design a framework which is actually uh, uh, like helping the drones to communicate for knowledge sharing. So in this they have brought in certain approaches which is actually useful to understand like how a drone network works. So so in this concept, like already in this paper, so when you're actually dealing with drone networks, you have to understand these particular concepts like what is UE. So that is user equipment. That is the actual device using which you are actually controlling the drone, or it is to the device with which the drone is actually communicating. Okay, then there is control links, then there is data links. Okay, so if from the previous session you would have understood like there could be control links from drone to drone also, and there could be drones that is actually acting as the user equipment. So you're supposed to recollect all the architectures that you have learned in the last session. So you have different possibilities of user equipments. It is not only the end user, it could be even the drones which is launched could act also act as user equipments, which is actually again in fact behaving like the controllers of the drone networks, etc. Then again you had a concept called clusters, where you are actually grouping a set of drones for actually a particular task within a region. So that concept is also there, where you call it a swarm of drones. Then again, here in this particular diagram, you can see a different approach. Actually, here one drone is having or controlled by multiple user equipments. That is also possible. Okay, so it is not like one drone is having one user equipment, not like that. It could be like one to one, or one to many, or many to one, whatever pair combinations. It is all depending upon the application or the requirement that we are trying to meet, how this architecture will be. But important parts are user equipments. There is always a controller, then there is UAVs. Now, by now, you should be able to differentiate what is the difference between normal UAVs and drones. Okay, so we are dealing with UAV networks, and again there will be control links and again data links. Okay. Now, in this particular paper, what they have done is these are the four things what they're trying to do. They have designed a SDN framework considering the dynamic characteristics of UAV network. So, what are the dynamic characteristics of an UAV network? So, that is very important to understand. So while designing, we have to understand that these drones are very resource constrained. So what will happen is like there could be chances that even before the particular mission is met, these drones could be drained out of their power, or they could be having some again it could hit somewhere, there could be a physical damage. So there are a lot of resource constraint which is embedded in the drone structure itself. Again, there could be possibilities that there could be some people who is hijacking it, or even the drones can go missing. So there are a lot of dynamic possibilities in the drone network. So that should be considered first. So based on that, they are actually creating a SDN framework. Then there is a monitoring platform, and there is a load balancing algorithm. And then we validate the feasibility. I mean, they are actually validating the feasibilities of that. Okay. So By load balancing, what they mean is, see, if there is particular information that needs to be reached out to this particular user equipment. Okay, so what could happen is, there is a multiple paths it can take to actually reach this particular user equipment. Okay, so it is not actually direct. It may not be direct communication. It can take multiple points to actually reach the final destination. So load balancing simply means that each of the drones that is participating in that particular mission or whatever, they should be given equal load. So these are actually the characteristics which you have to take care while designing a drone network. So one is, so what are the basic components of this particular network that they have designed is, one is the main thing is the UAV network, and it has actually the UAV connection. Then there is a UAV controller and the SDN controller. Okay. So in this monitoring, so as we have told, there is a framework that they're designing. Okay. Then there is a monitoring platform. Then there is a load balancing platform. So actually they are designing these three things. And the fourth step is actually they are checking if it is working fine. So we are understanding what is the speciality of the framework that they have designed. And again, one more thing, like SDN is actually software defined networking. So what is the importance of software? Like why we have to, why we are stressing on to SDN framework for a UAV backbone? That is one important question. So here the relevance of SDN framework is that SDN framework is actually something which is not designed for these dynamic sort of networks. Okay, so it has its own, like it is actually a software based networking scheme which actually controls, helps in managing the network and all. So this concept is actually basically for physical networks. So where you have a complete infrastructural based network, but this in this paper they are actually trying it to embed these features into a UAV based network. So that is the highlight of this paper, first thing. So how they are embedding us, they are installing a SDN controller, and UAV controllers are traditionally a controller that exists already. So if you take a normal UAV network, there will be always an UAV controller. Apart from that, they have gotten a SDN controller. So that is actually the addition in this paper. Now again, the monitoring platform has a monitor display, flow management, link management strategies, etc. So here you can understand that there are a lot of things like how many messages each drone is sending out, then the packet count, how much it is handling, the flow monitor, the flow path, now which path is going for each packet, like what path it is going to take, then the for each link. So if you remember this diagram, there is control link and data link. Okay, so that is what we call the link. So for each link, what is the load, then the flow table, then the packet outflow mode and UAV info, etc. Okay, so that is actually the basic architecture. So here what we have to understand from this paper is it is software based. So that is the first point. So in software based, like here what they're trying to like find out is they are predefining certain parameters to actually monitor. Like if you take any network monitoring schemes, you will actually see a lot of parameters, right? So if it is in, if it is out, then it will be set to 0. Then if it is out, then it will be set to 1. So similarly, here what they're simply doing is they are setting out and finding a lot of parameters which helps in actually managing the network. So that is basically the thing. So we also, like if you are actually designing a network, drone based network specific to our scenarios, we will also have to have a good understanding of what are the parameters that we require for managing the network. So it could be like the drone power left, drone fuel. I mean, if there is any fuel in requirement, then If it is a heavy levels, then there could be, like if it is a aircraft based UAVs, then you have fuel levels also that you have to monitor. Then if there is any hardware sensors, like if all the parts are working fine, then you have to have parameters representing that. Then again, the amount of data of like if there is processing going on, what is the CPU utilization. So all those parameters, like based on our implementations, we have to certainly identify these parameters. So that is how we can take the decisions, to which, like based on whatever decisions we have to make. So we have to smartly design these parameters. That is what we have to understand from this paper. So packet count, byte count, flow table, all those things. So how they have design the monitoring platform is, so if there is drones AB, then AC, BD, and EG. So here we have the different flows possible: flow to flow, so AB and CD, E, F, G, etc. So it is very simple concept actually. Then you have another flow 2 which is happening, then flow 3. So similarly, you will have a lot of flows that is happening. Then the final link load calculation is actually the sum of all these three things. So that is what they have explained here. There is a flow here. AB flow is called A1. Okay. And topology is AB is represented by A. So the complete A will be the sum of A1 to AN. So this is A1. Okay, this is AB. Again, if another AB was there, that will be A2. Then AB is there, A3. Then another AB is there, then AN. Okay, so sum of all those loads is actually A. Okay, so it is very simple representation. So that there is flows which is happening. And if there is a flow that is existing, it is called with the suffix A and the suffix I of flow. And the topology's load is calculated as small letter A, and a small letter A is actually basically the sum of A i's. Okay, so that is basically how the link load is calculated. Then they have monitoring parameters, as we have discussed, like there is the byte count, all those things that they are monitoring. And this is basically the load balancing algorithm. So in this algorithm, what they're doing is, see here, you can see that it is actually monitoring the network. Then there is load calculation. If there is an overload, then flow load to network variation is designed. Then parameter collection, priority of device numbers is taken. Then again, Dijistra's algorithm, if you know networking, that is how, like if you have loads, like you can find the optimum path. So basically it is using Dijistra's algorithm. I hope you all know Dijistra's algorithm. Shortest path, like minimum weight path, you know, right? Guys, are you listening?
Can you quickly explain?
Yeah, yeah.
Um,
Oh, it's
um okay.
no, wait, sorry, sir. Yeah, there should be some YouTube video. We can see it also. Short
Uh,
one.
yeah, it is very simple. Like minimum, like we assign weights to all these nodes. So only thing is that it will choose the minimum weighted final path.
Okay, fine. Got it.
It's very simple. See, we have this particular graph. Okay, so I have to go from A to Z. Okay, so I have multiple paths possible. Now, so these are the weights.
Mm,
So here we have load.
mm,
So this particular A values are actually the loads. Okay, so
mm.
that will be there in here. So in this diagram, this is the final diagram you have. Let me zoom it. This thing is zooming on. I okay. So it should be clear now. So this is actually the comparable to this structure. Okay. So what will happen is we will find all the load balances and we will assign this weight. Okay. So what we can do is we can find like if a certain communication needs to be made from A to D. Okay. So this load is 5, this load is 10, whereas this is 1 and 1. So we can choose A, C, and D.
Right.
As simple as that.
In real life, how are these weightages given in practicality?
It is basically if see, let's say one communication is established between A and F. So when a first communication is established, then AB node is taken. So it is assigned weight 1. Okay, BD is assigned weight 1, then DF is assigned 1. So this is having 1, 1, 1. Now there is another link establishment that is happening. Then again, it is A, B, and E. Let's say A has to send it to E. So what will happen is it anyways have to go to B or C. Okay, so when it is looking at the two options it initially have, so the minimal weight is actually going to C. So it can take the path A to C.
Okay.
Then C has two options, B or D. Okay, so then again, so it depends upon how we basically do it. Here we can actually do it at each of the communication establishment, or like after routine communication establishment. That again depends upon the software design. Like whenever a new communication link is established, then we can design, like this happens in networks also, na? Like which routing path we have to take and all. So those decisions has to be taken.
Okay.
So based on the registrar's algorithm, weight is equal to link load. So as we have discussed now it should make sense, like what is weight and link load. So it is exactly the weight. That is the link load is actually the weight. So based on that, we will actually design the finally find the path. Okay. So power threshold, we will keep on updating the topology. Then finally, power threshold is like met, then we will actually find the fix the path. Okay, so that is how we fix the path. Then we have sort by priority and switch over and end. Like I mean, that is again like if we have communications, like multiple communications coming in through the same node, definitely we need to maintain the priorities also. Like it could be priority based on the initiator. It could be priority based on some sort of parameters attached to the message. Like we can maybe whenever they are initiating the message, they could send there could be priority parameters attached with the message. Priorities could be set to 1, 2, with the range to 10. It is all software, like how we read it and manipulate the messages that we get. This is how we are completely talking about designing a software for managing the network. So we should think like SMTP designers, simple sorry, not SMTP, SNMP designers. SNMP,
Ma'am,
simple
what's the
network
full form?
management protocol. Simple network management protocol.
Okay, ma'am.
SNMP. Here we have a lot of a set of commands or messages, sort of like we send responses and back. Like it is predefined based on which actually the devices, how what they communicate back and to and fro, we will understand.
Okay, ma'am.
So this is basically designing something like that. Okay, it is not
Means
about security and all. It is
which is the tool used to, means who designs them, ma'am? Means I mean being specific.
See, we can have so many software-based solutions for managing network. SNMP is actually a standard. So which enables, see, if what will happen if each and every router is going to communicate, like every manufacturer is designing the responses that the router is sending out in its own fashion, what will happen? They will not be like one company's router cannot communicate with another company's router, right? So definitely we need a standardization for managing these communications. So that is where SNMP comes into picture.
Yeah, got it, ma'am. Actually, it's a protocol. Okay, ma'am.
Yeah, it's a protocol. Yes. But ultimately, it is actually a management thing. So it is like a set of rules, like definitions, how they are communicating. Same thing we are designing here.
Okay, ma'am.
In the drawn network, what advantage we have is we can design it based on our application.
Okay.
By that, by designing it specific to our application, we can optimize a lot of communication. Did you understand? See, simply we can like, there could be like something where the drone is facing some issue. We could have predefined that situation using a parameter, and the drone will initiate that command or that parameter. We can simply communicate back that, okay, this particular issue is coming. If we could have predicted all the sort of issues that the drone could have faced, and we have already predefined numbers, like let's say interrupt 1 to 10 or interrupt 1 to 15, something like that. So let's say the wings are having issue, or the propeller, some motor is having issue. So there could be sensors that is finding it out now. So what could happen is, like, if the hardware based issue is simply sorted out as one parameter, like when the sensor is finding out that propeller is having an issue, if we have not filtered it out and specified a parameter, we'll simply get the information that a hardware is facing an issue. But if we had predefined it to take the sensor information as such, and in the drones level itself, we will actually set out multiple parameters for actually finding out what is the actual hardware issue. Then at the end point, at the user equipment, we'll get the correct information. Okay, the propeller has gone wrong. Did you understand the difference? But like,
Yes, ma'am.
why we need these management things?
Yes, ma'am.
Okay. So yeah, so that is what people are focusing, basically focusing in, like when we say management based solutions, network management based solutions, making the communications effective and without increasing the load on the network.
Okay, ma'am.
Then so that is a load balancing algorithm they have designed. And then again, they have done sort of analysis and all. So here what they have done is, like, they have shown two considerations. Like let's say, this is a very simple.
Ma'am, actually, have you zoomed the paper? We can, means I am seeing half of.
Yeah, I have seen zoom the paper. This is the diagram I'm talking about. This particular graph.
Okay, bar chart.
Yeah, that's it. This one.
Yes, ma'am.
So in this, what they are discussing about is, like, they have done a very simple and beautiful analysis actually. So they have designed load balancing. They are focusing more on the load balancing results. Okay. So what they're trying to achieve is, they are trying to balance out the load for each of the drones. Okay. Here you can see that without load balancing, you can see that almost all of the drones are having varying like levels of loads. It is a very simple and beautiful analysis. Okay. You can also like think about generating papers like this, because it is very easy to do, and we can definitely, it is doable actually. So yeah, so without the load balancing, blue is representing that, and with load balancing algorithm, this is the status where you can see that almost all of the drones are having somewhat similar. Here in without load balancing, this particular drone, UAV, is having more load on it, whereas with the load balancing, this is the same. Then now they have considered, they have done their analysis based on battery consideration and without battery consideration also. So what is the difference is that, see, let's say
Ma'am,
this
what is these AP full form? Means AP1, AP2. Is it the name of the drone?
um,
Means actually I did not get so.
I believe they have simply named it as AP, UAV AP, that's it. I I don't know if there is a specific reason like why they're, I do not think about that. UAV is actually AP, that's it.
I thought it's abbreviation, ma'am. So okay, ma'am. I don't know,
Ah,
but
yeah. Now, when you asked, I also started thinking it could be an abbreviation, but I don't think so. It is an abbreviation. They have simply named it. So I guess, let me see the other diagram. Let us see this diagram if they have called it AP. No. Anywhere else, they are referring it as AP.
ma'am, it's for
No.
aerial photography, mean in drone terminology. As the quadcopter has that capability of taking photographs of objects on the ground from various elevated positions. Means AP stands for aerial photography, ma'am. I think so.
But why should they name it as AP1, AP2? Aerial photography one,
Means
okay, maybe
uh,
they mean that the data could be sending to, I mean, it is AP. Yeah,
I
let
mean
us put that as 10.
in that
I'm not able to find.
means UAV1, UAV2 means by naming that it looks something means lengthy. So I think they have used it.
Yeah, I did not find any relevance. Let's see. You can also read and give me a relevance. That is a task for you.
Okay, ma'am.
I just felt like it is a naming, but definitely there should be a sense to that. There could be a reason. You can find it out. Here they have simply put UAVs in the bracket AP. So I am suspecting that it is just a terminology that they use. So I
Means
did
on
not
the
go
right
much.
hand side, even they have means mentioned many types. Means
Yes.
AP1, AP5.
Yeah, like aerial
Means just
photo.
in the form of it's a name of a person. In the same way, they have
Huh.
segregated that drones with that names.
Yes, that is what I also felt. But if there is some other significance to that abbreviation, you can find it out and let me know in the next session.
I don't know,
The
ma'am. I
task for
just
you.
Googled it and that was what it came out.
Yeah, okay. Yeah,
I
it is
mean,
actually a relevant question. I also felt like
what else
when I
may be
read
the
the paper,
full form, ma'am? I don't know.
maybe like in drone concepts, na, maybe they are also abbreviated, like UAVs could be abbreviated as APs also, maybe. AP in UAV terminology, if something is there. Airplane. Oh, that's it. Airplane. So that could be the reason.
Yes, ma'am. I think this is the right one. Actually, I was wrong.
So it could be
Airplane.
this.
Okay,
Air,
airplane one, airplane two, airplane three,
yeah,
four, five.
yes, that makes more sense.
Yes, ma'am. Then aerial photography.
Okay. Yes. No, no, but it is very good. Like keep asking questions. It is very good to be interactive. Yes.
I mean, yeah, as it was zoomed, I was able to see it. Means the clarity was
Okay.
more, so I was just focusing on everything.
It also shows that you're thinking.
Okay, ma'am.
Okay, so yeah, so that is one comparison. So they have also considered battery. So that is the beauty of this paper. Okay, like how they have compared their own analysis is, one is like, let's say this particular drone is having minimal load, right? So blue color is very low. But what happens is, if this particular
Zoom
drone,
in, ma'am, please.
so if this particular drone is having minimal load, but still it is having lesser power, battery. Okay. So if we'll actually increase its load, then that particular drone can go dead very soon, right? So what they have done is, while load balancing, they have taken battery also into considerations. Okay. So that is the next analysis. They have done, like, without battery consideration, load balancing without battery, and load balancing with battery. So that is how they compared it. Okay, so that's all about this one. So with battery consideration, so they have assumed that AP3 is going to like die of battery issue. What they did is, they have kept the load of AP3 as such, and they distributed the load amongst others. Okay. So it is because of what one? Why they could actually do it? What is the significance of battery consideration? Like, we design certain parameters initially, na? So what they're trying to tell us, by actually designing certain network parameters initially, we could actually balance the load considering the network parameters. So that is what they're trying to conclude. Do you understand?
Sorry, ma'am. Can you please repeat it?
See, in the first stage, what we designed is, we designed certain parameters which actually tells about the battery power left, okay, the height in which the drone is flying, what is the packet size that the drone is handling, what is the CPU utilization, what is the current location, GPS location. So there are a lot of parameters which we designed in the first stage, okay. Next, what we are trying to do is, we found out the load in the links.
Load in the
Links. There are data links and control links, right?
yes, ma'am.
So we found out the load in these links. Okay, basically data links. Okay, what is the load they're going? Then we talked about the algorithm they have designed.
Okay.
Now they are talking about optimizing the load. Okay, so what they're telling us, when we are optimizing the load, we can actually make use of the parameters that we have designed in the first step. One of the parameters, they have taken the example, which is the battery power.
Okay, ma'am.
So they are combining it and telling that, when you can actually, it is not a mere load balancing technique. We can actually combine it with the network parameters and make it more effective.
Okay.
So in this case, it is just the battery power. We can actually introduce the distance, okay, distance from actually the user equipment. So if the drone is very far away, maybe you need not, we might be having worry about whether the drone will, if it is a restricted area, maybe the drone will come back or not. Like after 5 seconds also, if we are not responding if we are not getting any response from the drone, we can initiate a suicidal signal to the drone. It can burn off itself. So there are a lot of things that we can do with these parameters that we have designed. Okay.
Means what is this suicidal signal, ma'am?
It can burn off itself. See,
Means
we are talking about
self-destruction.
Yeah, self-destruction. Yes.
Okay, means
Like
in order
yeah,
not to means leak any information, means in sort of something like that, right, ma'am?
yes, similarly. So
Okay.
what we can do is, we can like in the processor itself, we can create so many like heavy load instructions, and definitely the CPU will burn off, na? So there are different ways you can kill off a hardware. So we can initiate that thing like artificially, and we can make it behave suicidal.
Okay, ma'am.
So yes. Any doubts? Like I don't know who was communicating more. I believe it was Naveen. Yes, right?
Yes, ma'am.
So Manohar, Mitapili Manohar, you there?
Yeah, there, ma'am. I'm
Do
just
you have any
listening.
doubts? Or
No, ma'am.
okay. So now this is okay. So in this paper, this is again a paper which talks about good a good scheme. Okay. It is actually a routing protocol based, and you can see it is from HL. Now in this paper, it is a very good paper. You will have to go through it very clearly actually. So in this, they are actually specifying this features that define it, the network connectivity we are using, the number of nodes, sufficient energy, then the mobility that is required, the propagation model, strict delay constraints, all those features that is there. Another important thing that is conveyed in this paper is the different attacks that comes in. So it is very important for us. Why? Because this paper is also there, and there is one more paper which I'll again discuss in detail. Okay. In this particular specific to, okay, so in the last session we had discussed certain threats and attacks that is possible. Now this particular attack is specific to routing. Okay, so why routing is important is like in our scheme we are not exactly designing a routing scheme, but we are actually designing a authentication based or authentication come data exchange. Okay, so we are not worrying about the complete network association, but if we are going ahead and building up, that is our target also, like building up a pure drone based network from the scratch. So that is also there in plan, right, Sam? Sam, you there, right?
Yeah.
So if we are actually going ahead and building such a network from the scratch, definitely we'll have to do all this. We'll have to design the hardware, then we'll have to do the network management, like the network architecture levels. All these things needs to be done. But right now we are more focusing on like the authentication and the data communication part only. But again, to secure that part, we have to understand what are the different attacks that could happen in between the nodes. Okay, so definitely we have to understand the different routing attacks specific to these ones. So again, flooding attacks is there, replay attacks is there. So replay attacks and all is similar to what could happen in a normal cryptographic attacks. You know these attacks? Flooding, replay, bisending, colluding, all those.
No, ma'am, actually.
Spoofing, okay, let me say like brief on these. Okay, so flooding attack is basically last day we talked about denial of service, you remember?
Yes, ma'am. Yes, ma'am. Resistance to denial
So
of service.
it is similar to that. Like we can say that denial of service is actually a flooding attack. Okay, you are flooding the server or that particular person with lot of requests. So what happens? The actual users won't be able to get the resources. Okay, so that is flooding attacks. Then did you understand flooding attacks? If you're not able to understand, stop me, okay?
Actually means explain with other example means. Can you explain me with other example, ma'am?
Okay, then other scenario could be like in significance of it is actually protocol based. Okay,
Actually, I assume that flooding attack means as it was means multiple or many people or information which attacks means which comes at a single point of time. Means
this is actually like we can talk about sin is acknowledgement attacks. So if we are actually, this is actually denial of service. UDP flooding. Okay, so denial of service could be done using TCP, UDP, SYNC acknowledgement or HTTP flooding. So there are multiple flooding attacks that you can do. Okay, so here what happens is there is spoofed UDP packets that is going into the server. So attacker is launching initiation to these zombies. Okay, so what will happen is these zombies are actually generating the UDP packets. So this is called UDP flooding. This is called synchronization acknowledgement flooding. Now there is.
ma'am, what is that UDP means full form? Is it again the protocol means UDP protocol?
No, it is protocol.
Means
Yeah, I think
what
it
does
is a user datagram protocol.
user
TCP
Datagram
is there, na?
protocol.
Transfer control protocol and user datagram protocol. I am assuming I am actually talking with the assumption that you have networking and cryptographic, like networking basics is different. Cryptographic is different. Like cryptographic basics we can understand, like we can explain, but networking basics is very important actually to design these networks. So you both
actually I am new to both of them, ma'am. So I am just asking.
okay, can you tell me your background actually? Like you are from
Nothing, ma'am. I am just a mechanical engineer who
okay.
has worked for
Which
1 year. Okay.
which year? Mechanical engineer, which year?
18 passed out.
Huh?
2018 batch, ma'am.
Okay. And Manohar, you are?
I am from CSC background and final
Okay.
year student.
Okay. So you both are from which location actually?
Telangana. I am from Telangana.
And
Ramagundam.
Naveen?
Mysore, ma'am.
Mysore. Okay.
Mysore.
No,
Yes.
it's fine. Totally fine. What you can do now, like I'll tell you. Okay. The important one is like TCP IP layers. Okay.
Again, what is this TCP IP?
Yeah,
Just write down.
like
Just
ma'am,
write
in
down
my
what I'm
third
telling you.
year. Okay.
No, I mean, no, Manohar, you will be aware of, but for Naveen, I'm telling. Naveen, just write down these terms I'm telling. TCP IP model, OSI model.
Just a minute. Can you please repeat it, ma'am?
What I'm showing on the screen, the OSI model and the TCP IP model.
Okay.
See, for what work we are doing, we need not get in much detail, okay? As I have told, we are not focusing on the designing of network right now. We are designing the security aspects. So you need not break your head understanding all this, but the basics is very important. Okay. So what you have to go through is like watch a video on OSI model. Okay. Watch a video on TCP IP model. Okay. It could be like 5-10 minutes videos. Okay. Don't
Yes,
go
ma'am.
for very big videos and all. Then what you have to understand is in each layer, very important, in each layer, what is the devices that is being used, okay? And what is the protocols that is being used.
Okay, ma'am.
Like in physical layer, we have the cables and all, okay? So in that, we basically use Ethernet as the protocol. Similarly, in all these layers, okay, we'll have some devices and protocols to actually handle. Just watch 2-3 videos relating to this. You will get what idea is required. That's enough.
Sure, ma'am.
Okay. Okay, so where was that paper? Okay. So that is, okay, so so just understand that all these protocols has its own way of working, okay? So it will actually like send a request. And again, Naveen, you also have to watch this video, TCP/IP, I mean TCP and UDP. It is also very important. Like how, like these, and you can choose, as we have told in these layers, there are a lot of protocols, na? So each of these protocols, like you can choose some of these protocols and watch videos on them also. See, why I am not actually thinking of giving you a session on it is because we really do not need that in much detail. So we need not spend so much time on that. For your knowledge, you can simply go ahead and read it. And in in YouTube, you will see a lot of interesting things. I'll show you like.
It's okay, ma'am. Actually, I will see I will see
Can
them.
simply see like TCP model explained using animation like this, right?
Yes,
TCP
ma'am.
IP stack and using with real world example. Watch videos like this, not boring stuff, not theory stuff. Okay, simply watch videos like this only.
Okay, okay, ma'am.
There is these sort of videos, so this will give you a good idea.
Sure, ma'am. I will watch them.
Okay. Yeah. So I guess for today it is good. We will continue tomorrow, right, Sam?
Yeah.
Yeah.
Actually,
So
it did not feel like an hour, right, sir? I don't know, but it just felt like 10 minutes.
it's actually an hour.
Okay, ma'am. Sir, tomorrow at the same time,
Yeah.
10 to 11.
Tomorrow, same time. Yes.
Actually, Sam, he was telling like it will feel like an hour.
Yeah, yeah, I know. I'm here only.
Actually, if it is a discussion like this, I will understand more and it will be what we say. I don't know. More we absorb the knowledge more. It's my opinion. But if
Yeah,
it's only in a listen only mode, I get bored, ma'am. I can't just focus. I don't.
yes, definitely. That is same with anybody in this world, I believe. Like nobody can focus on being in a listening mode. That only with music or movies that can happen.
Yeah.
Yes.
All
Okay,
right.
sir.
See you guys tomorrow.
Yeah.
All right. Okay.